So I made sure I wrote that information on it. That'd be great. If you don't have it available anyway, you can guide from what we see here. The thing is that after I briefly explain them, I'm going to erase. We are talking about circles in this. In 10.1, we were kind of learning some vocabulary related to circles and some parts of the circles depending on what you are drawing, right? So just quickly, to quickly remember, what we're going to talk today is chord, but that segment does not necessarily have to pass through the center of the circle. A segment that connects 2 points in a circle that passes through the center is called the dichord. Okay, so we're going to talk about and define 3 theorems, but the second theorem is split into. A theorem tells you the following: you have the circle, you have the first chord AB and the second chord CD. So what happens and what is the condition? You can say that, contrast to this straight mark on top, this is referring to a segment and this is referring to a chord. Remember that. And remember that we have minor chords and major chords. So we're talking about this minor chord. In this case, just so you remember that what is that chord about is the angle that is sweeping from one point. So this chord is arc is this portion, and it encompasses or sweeps this angle. And it's formed because I did these two arcs. Okay, this arc right is this chord right here and this chord right here. So the thing is that if minor arc AB is congruent to minor arc CD, right? So let's say that this and this angle are congruent. If that is the case, then I can say that the segments find some missing values as usual. Now, let's take a look at this second one. All right. Say hi to Heidi. Hello, Heidi. Yeah, hi. I have a circle. Look at EG. And this is the center. So EG is a segment that connects, these 2 points, Z and G, and passes through the center. So we know it's a diameter. All right. And now we have this green one. It's a chord, right? And that chord happens to be perpendicular to this diameter. All right. So look at this. This is the statement of this theorem. If the arc GD, all right. Remember, whenever we're talking about arcs, we talk about this. This happens if the diameter and this chord are perpendicular. Then the arc from GD, or the GD arc, and the GF arc are congruent, as well as the portion or the segment HD and HF. All right. So I could say that this is what happens, right? Going to kneel down a little bit. Okay. So the one we have here is, oh, too much light. Anyway. All right. So it's related to the one we just analyzed. The thing is that it's the converse one. So in this case, what segment happened to be perpendicular. And I mean, if this segment SQ happens to be the perpendicular bisector for TR, then that is the reverse process. All right, just that's all. Okay. Now let's talk about the last one. The last one says this. Let's first understand what you see from the circle. We have a circle, we have its center, we have two chords, and we have the distance from the center to this chord and the distance from the center to this chord. So this would be EF and this would be EG. All right, so look at this. Are congruent if and only if EF and EG are congruent as well. So it means that if this is true, the blue marks I just drew. If this is true, then this is also true. That I'm gonna try to not erase this because they're so beautiful and I don't want to erase them. What do you think? I'm gonna try hard to do it and using time. So let's begin with, I'm going to explain example number 2 from the book. That's on page 591. All right. And that exercise is telling you the following. All right. Um, well, actually, yeah, never mind. Actually, I'm going to skip this a little bit, and I'm going to start doing exercise from an exercise from this one. Okay. So here we go. I'm going to erase this because I suppose that we already understand what it means, right? So here's the thing. We have the following thing. Actually, I'm going to do extra example. I don't want to do the one from the book because you already have it. I'm going to do another one. All right. So in this case, we're going to use the diameter, and we're going to use a chord. And what information are we given? Let's see. We have, right. So we are going to be given this information, right? We're going to be given the minor arc, the measure of the minor arc GF, okay? And actually, they don't give it to you just like that. They say that 127 minus x, all right? This arc. And now, let's say that the measure of the minor arc GD is 2x minus 8. All right. With that information, okay, we need to find out KH, which in this case is the length of, wait a minute. I just want to make sure. Yeah, we need to find out FD. All right. So we need to find the length of the chord. All right. And also we will need to find the measure of the major arc. In this case, it's gonna be HLK, which goes HLK. So in this case, we are going to have to find the major arc that goes FED. FED. All right. So this is the exercise to know. So this exercise is telling you that the arc GF, its measure is 127 minus x. All right. This. Also, we are given this other minor arc, GD. Its measure is 2x minus 8. With that in mind, the major arc, this one that goes from F to D, the minor arc. Is that it? All right, that's it. So let's begin. Let's begin with that. So we are going now to say that because of the theorem, right? Because of this theorem, we know that this and this are congruent. If these two are congruent, what I can say now, it's this. We have. Am I doing the right thing? Sorry, give me a sec. Okay, let's. Oh yeah, I missed this information. That's why I was a little bit confused. We were also given this information, NK, which in this case happens to be this. We're given GF, GF, GF. This is 7. Okay. All right. Now it makes things pretty easy because I say, hey, what was going on? All right. So this measure here is 7. And because we know that this is 7, this is also 7. So FD, the whole thing, is 14. Right? FD is 14 because we were given this. And now we want to know this major arc, right? The first thing we could do is finding out the measure of this or this minor arc, which we can find by setting them equal to each other. This is 127 minus x equals 2x minus 8, right? So you are going, right? So you're going to have 135 equals 3x, correct? So we know that x is going to be 45. With that, we already know what x is, but that's just telling you what x is, but not the measure of the arc, all right? So in other words, you can plug it in here or here, and you will be able to find the measure of one of the minor arcs, right? So here we go. Let's draw this line here so we know that we're talking about this exercise, okay? So here we go. Now we know what x is. You can find it, you can plug it in either here or here, and it's gonna be the same. I prefer to do it here. So now we know that the minor arc GD is 2 times 45 is 90, minus 8, it's gonna be 82, all right? Now, we currently know the measure of this minor arc. Since it is congruent to this other arc, they measure the same, so it's also 82, right? The thing is that we have one is. So these two together are 164 degrees, correct? This whole portion, 60 minus this, all right? Which in other words would be 196, all right? From, all right? With that in mind, well, guys, that's what we had to find. FD, which is twice as much as this, which we already know. We know part of it, but we just had to multiply by 2 to get to know FD, the length of the chord. And if we wanted to find out this one, we first had to find out this one, this chord, which is cut in 2 congruent parts, GD and GF. Eventually, we got FD. FD is 164, and then the whole thing is 360. And if you subtract this portion, then you will get this major. So the second one is in page 592, and I'm going to keep this information. I'm going to erase this. All right. Let's see. Okay. So we are. What information are we given in this case for page 592? Well, I'm going to do an extra example 4, but it's similar to, it's going to be about this, all right? This and this, all right? They tell you that GC is 5x plus 7, and AF, I'm going to write it here, AF is 7x minus 3. To find the radius, it means that the length that goes from this point to any of these points. That's what we have to find, all right? But the thing is, I need to make sure I locate it in the right way. Drawing it here, it's just a way to say, okay, yeah, this is a radius. This is another way of saying this is the radius. And I want you to see this, guys. What is this? We're talking about angle. And if you see that, you can use the Pythagorean theorem to find out the value of r, right? So with that in mind, I can say, well, if I know this, the short leg I can find the length of the long leg and then of this leg. The thing is that because of this theorem, we know that this segment, this chord is equal to this. And same thing here. So AF and CG are the same, right? So if I say that AF and CG are the same, so then I could say that, look at this. This is the, okay? And then I can solve for x, and when I find x, I plug it in, and I will eventually know what the length is, all right? Which in this case, we go like this. This is going to be 2x equals -4. Okay, so x will be -2. It's okay to have a negative number because that's not the length, the actual length, all right? Well, wait a minute. Are we sure? Oh, I made a mistake here. It's not -7, it's +7. Yeah, the problem is not about the x, but it's going to be a problem if eventually you get a negative value here. This is +7, so this is going to be 10, and then x is going to be 5, all right? With that, I will know that AF is, for example, 7 times 5 minus 3. That is going to be 32, all right? So now we have 32 here and 12 here, right? This is R. This is the distance from the center to the chord. And this is the value of this portion, that is 32, 12 squared. All right. So now let's do these calculations. All right. And then that's going to be all. Wait a minute. Let's calculate that. So 32 squared. Okay. Let's do this calculation. So 1024 plus 144 is 1168, and right, we got 34.17. So R is 34.18. Okay, and we're good. Things to take into account. Remember, the radius is always kind of being as the hypotenuse on those sections. If you have questions, you can send me an email. But we're done for today. All right, thank you so much. I'm going to stop the YouTube live, and then I'm going to stop our meeting.